Let's talk about using the periodic table to write electron configurations of atoms. We have to understand that each orbital in an atom builds on the ones that come before. All the orbitals are already there all the time, even in hydrogen, waiting to be filled or occupied. Now let's talk about the 1s orbital. It is of course the lowest energy of the orbitals, and we have here an equal probability surface for this spherically shaped electron cloud. Each point on this sphere has an equal probability of having an electron. Here's the 2s orbital. As you see, it is larger, the same probability across the sphere. Here's the 2px. It'll hold 2 electrons ultimately. Orthogonal to it, the 2py. And coming in and out of the screen, the 2pz. So number 3 of these 2p orbitals is available on the second energy level. Here's the 3s. Again, its average distance is larger than the 1s or the 2s, and it can accommodate 2 electrons just like every other orbital. And you also have a 3pz, x, and y, along with the 3s. After that, you start filling the 4s orbitals. Now, we always add electrons to the lowest energy orbital that isn't already filled. That's the Aufbau principle. We never put more than 2 electrons into an orbital. That's the Pauli exclusion principle. And if you have degenerate orbitals, like the 3p orbitals that are available on the second, third, and fourth energy levels, you will half fill them before you completely fill them. That is Hund's rule. So we start with hydrogen. All its compounds suggest that the atom bonds only one time. It has an atomic mass of 1, so it must mean it has only 1 electron. The lowest energy orbital is the 1s, so the Aufbau principle tells us that the hydrogen atom has an electron configuration of 1s1, and you can see the electron as a kind of a half arrow here. It now has the 1s orbital. It had it before, but now it has 1 electron in it. Helium, the first noble gas, so a low energy element, it never reacts, so the 1s orbital must be filled. There are 2 electrons in helium, and so we have 1s2, 2 electrons in the 1s orbital, and the box has paired electrons, one with a +1 spin, the other with a -1 spin. Now the 1s orbital has 2 electrons in it. Now this periodic table recognizes the unique status of hydrogen and helium by setting them off in a kind of a family by themselves. It also gives us an opportunity to define the s block as those elements characterized by adding s orbital electrons. So in here, the characteristic or last electron added will be an s electron. Likewise, we have the p block. Over here, the last 6 elements on any row are characterized by adding a p electron. The d block here in the middle is characterized by adding a d electron as the characteristic electron. We have to remember that each of these is going to be on an energy level 1 less than the actual row. So in this area we are filling 3 d orbitals, even though here we filled the 4s orbitals first. So let's look at period 2, and we always begin at the left where the less electrons are being added. Lithium 1s2, 2s1. It builds on the noble gas configuration of helium, adding one 2s electron to the helium configuration of 1s2. Beryllium, 1s2, 2s2. This exhausts the slots in the 2s orbital. The 2s orbital is filled. Boron. Now we have shown the three 2p orbitals. Boron adds an electron to one of the 2p orbitals, and it is 1s2, 2s2, 2p1. It's added an electron to the next available orbital, the 2px orbital. Carbon would be 1s2, 2s2, 2p2, and nitrogen 1s2, 2s2, 2p3. Here we are adding again to the next available p orbital. Now we have half-filled all of the p orbitals in the second energy level, so oxygen, which has one more electron, will totally fill the px orbital. Fluorine will completely fill now 1, 2 of the 2p orbitals, and neon will fill all of the 2p orbitals. So between them they have 2, 4, 6 electrons. Neon is 1s2, 2s2, 2p6. Now the second energy level is full with complete s and p orbitals. Experiment tells us that neon does not react. It is a stable low energy element. Sodium starts a new ground state energy level, the 3s. And so we have everything filled here plus a 3s electron. Magnesium continues to add. We now completely fill that 3s orbital with 2 electrons. Again, all the electrons of neon plus 2 3s electrons. We will see that when we have, for instance, something like magnesium, we can just write the Ne in brackets. That tells us the same thing as 1s2, 2s2, 2p6. It's called a noble gas shorthand or a noble gas shortcut. You'll learn more about that later.